Hello and good day to you. So today I'm looking at nave Bayes and doing a video on it. Nave Bayes is something that fascinates me. It's this formula here: the probability of class given event equals the probability of event given where class is true times by the probability of class divided by the probability of event. So in this case it's saying that the probability of having the flu, given that I have a runny nose, equals the probability of runny nose where I also have the flu, and you can go and count this, times by the probability of flu in general across the population divided by the probability of runny nose. Now, the guy that came up with this, Thomas Bayes, thought this was so obvious that he never actually published it in his lifetime. It was only after his death where his notes came to light and were published by Richard Price, and it went on to be seen as one of the biggest breakthroughs in probability and statistics of that era in the 1700s, and it's now used in lots of machine learning. So what he considered so blindingly obvious is a massive breakthrough. If you go and read up about the man, very interesting Presbyterian minister, statistician and philosopher that studied theology and logic at Edinburgh, as you do. Now, because this is maths, you can revert it, so you can change this to have any one of these numbers as the main thing, so there's nothing stopping you from moving this round, and that will get you. So because it's actually maths, it is manipulable like that. If you have a single value that a couple of values that you can then go and look at finding out the unknown value, which is where it becomes quite useful. That's not actually code, so I can't run that. But I'll let you do it very quickly. Use a library, E1071, and you can make a model as normal. Prints this out. Now, what R lets you do that's quite clever, if you've got to this point where you have an estimation of these values, there is nothing, and the nice thing about nave Bayes is it's very efficient to run in code. It's just open up three dictionaries, say, and do a count of the various values as you slice through the data. Where I've had somebody point out that there's other ways of doing the maths, there's other ways to count for one variable, and that's correct, but this is the most efficient to count for all your values that you're looking through if you were to go through the data in one go. But you then get to a point where if you say, I want to know, and this is where it becomes a classifier. If I say I know that I haven't got the chills and I haven't got a runny nose, and I've got a headache, and it's really strong. And I've got the fever, and I want to know, first of all, what's the chance? I've got the flu, and that's the value I've got for no. And if I do run the same thing again for, which one did I say? I said strong, didn't I? And if I do the same for the yes, I think I said I hadn't got the chills. Did I say I've got the chills? I think I've got the chills. Let's have a quick look. No, I said I haven't. I've got it because it's the first one. And so I can see that yes is bigger than no, and I don't need to do the division at all because I don't need to normalise it back into proper probability. I'm quite happy with these values being low because I'm just going to compare the two against each other. And this is where they say naive Bayes is a bad estimator, because if you were to do all this maths and try and divide it by something to normalise it back into percentages, you tend to get a value that's over 100 if you add the percentage for yes and no together. They don't quite fit together because of a whole bunch of reasons. So it's not a good estimator. It's not a good way of working out exact percentage of events if you times all these things together and multiply them. But it has a really good accuracy of just saying probability given a bunch of information about one person or another, whether you should classify them into one group or another, which makes it a really useful classifier but not a good estimator. The use cases are things like fraud detection, risk categorization, spam filter, and as you've seen in this, medical diagnosis. The ability to combine these different variables and the ability to do this sort of look at these values and sort of pick out which one is the one that increases the risk the most is very valuable. And just like normal in R, you have the benefit of being able to use predict, drop in your model, drop in your data, and it'll work it out. So I hope that's of some use. It's a very simple algorithm, and I've done a very, very simple job of explaining it. I think I have to learn more because there's all sorts of Bernoulli and Gaussian methodologies around naive Bayes which are useful for different situations. I've used it in a couple of cases, and I've always came away with the idea that it's a great rule of thumb, which is what I said, it's a great estimator. So it's a great rule of thumb, so it's a great classifier, but it's not a great estimator. It's not something that you should use to work out, given all these facts I know about this thing, this is the probability of the event, but it'll tell you whether you should think that the event is more certain or less certain, and whether you should consider that there's enough evidence or not enough evidence, which is useful. So I realise that's a really simple case. It's something that I think you should go and spend some time on, something maybe brilliant if you've not seen it before. I find that you can find word games with it once you understand it a bit, and it'll make you'll trip over it a good couple of times, as I've definitely done, where I've sort of not worked out, going back to that, it's very easy to confuse which one of your values is which one of those probabilities. I don't think it's the most interesting thing in the world, but I consider that you can't really get much further in statistics until you understand it, and I think I need to put some more effort in myself to really grasp every bit of it and understand probability and how you analyse it in a much deeper format. So thanks, have a good day, bye.